You ought to be able to download it again if you submitted it.
Oh, I submitted a screenshot of the results, not
Yeah.
the code.
Okay.
So, you can download the output.
Alrighty. So the first three are effectively, little math problems. So that's the kind of thing where you're just doing. You're not even having to do any input until step 3. 1 and 2 are calculations. So let's maybe do 2 and 3. Skip 1 because it's very similar to 2. And then we will take that and we'll run with the idea. So what I want to do after we just do the demonstration of 2 and 3 is to modify it so that couple of things. We want to make it menu based, so you choose which one you want to do, because that way you could do them all in one script if you wanted to. And also to make it where the input is bulletproof, where it doesn't blow up. I think I did that last time, but we're going to do it again.
Yeah, we talked about it.
So we won't spend much time on that. And looping. So I want it to loop. I want it to have a menu. But before we do that, let's just get it going. So, name, assignment, date, that kind of stuff. Alrighty. Write a program that computes and displays the perimeter of a letter size. Okay, what's the perimeter? It's the height plus the width plus the height plus the width. We can make it real spiffy by using some, constants to hold 8.5 and 11 so that later on if somebody else wanted to calculate it in centimeters or something like that, they could. So why do we do that? Height is equal, I'm not even sure why I'm making it all caps. Height is equal to 11 inches. Width is equal to 8.5. And then perimeter, there's more than one way you can calculate it. It's height plus width plus width. I'm going to do a shortcut for it. 2 times height plus width. And let's tell the user what we have done. The perimeter of a letter sized, isn't it? Yeah. I don't really need that. Get lost. Okay. The perimeter of a letter sized piece of paper is %.1 D. Doing some formatted output. You don't have to do it that way. And what are we going to fill in the placeholder with? We're going to fill it in with the value of the parameter variable. Now I'm going to run it. Oh, by the way, one of the reasons your Python setup can just suddenly start failing completely is because you accidentally save something into the default folder. When you do save as and it comes up in Python 3632 or whatever, if you save stuff down in here, sometimes it works great, sometimes it breaks Python to the point where it won't load. If that happens, go and look in those directories for a file date that doesn't match the others. Alrighty, so feb27.py. I shouldn't put spaces in my file names. Python supports that, but other programming languages don't. Okay, so there we go. Going to test it out. Run early, run often. I hope that's the right answer. Okay, so we have done the first problem, or actually the second problem. Now we're going to do the third one. Reads a number and displays the square, cube, and fourth. Use star star only for the fourth for some reason. Okay. So we need to read that number in. Getting input requires printing a message, using the input statement, and then converting it to a number. You can do that all in one line. You could do it in 2 lines. I'm going to do it in 3. Print in the number to do math on. How about that? And then num is equal to input. And then num is equal to float. Num. And I could have combined all that into one input statement. This is what it would look like if it was combined all into one input statement. Right? Like that. Without the extraneous spaces. You like doing it in one line? That's great. Like breaking out into three? That's great. All right. So we could just print them out, or we could calculate the values first and then print them out. I think I'm going to do that. I like storing my results first. So we need square, cube, and fourth. So square is equal to num times num. Cube is equal to num times num times num. And fourth is equal to num star star 4. Then we can print those things out. Print. Square is comma square. Print cube is comma cube. Let me push that up a little bit, make it easy to read. And then the fourth is, that ought to be called the hypercube, or the tesseract value of it. All right, anyways, fourth.
It is. Can't call it hypercube.
Yeah. Okay. So maybe that'll work. Let's run it, make sure I don't have any typos and stuff like that, and I would like for y'all to do the same. If you have typos, let's catch them now. Alrighty, I want to do 10. 100, 1,000, 10,000. Okay, so what I want to do now is I want to turn these into functions. Now this is enough for the homework assignment. Just do part 1 in addition to problem 2 and problem 3, you know? And you're good. So, you know, just stop here, modify it, add problem 1. Don't do it right now, right? You know, because we're going to keep typing. But that's the idea. We have gone far enough to handle that much of the homework assignment. There was something else down here at the bottom, perhaps? Oh, just something typing in and running it. Turtle program. Okay, so what I want to do is I want to turn these into modules. Sorry, I'm using the word module. Been teaching too much fundamentals where the book calls them modules constantly. I'm going to put these into functions. So def problem 2, or even P2 would work, colon. And all of that stuff needs to be tabbed over. And if you feel like putting a return statement at the end of it, great. Problem 3, def problem 3, we've defined another function. Now these aren't taking any arguments, so I'm not defining any parameters between the parentheses. And I'm just tabbing everything over there. All right, now I want to make, oh, did everybody get that other one to run, or were you getting syntax errors? I'm sorry, I didn't do a walkabout. Please wave your hand if you got syntax errors, even the people behind the pillar so I can't see. Hey, how you doing? All righty. I want to do that thing where I do the if underscore underscore name is equal to underscore underscore main. So we're going to write a main function as well. Define main, colon. The first thing I want to do before I make it do fancy stuff like, you know, loop and things like that and call menus is just to call problem 2 into problem 3. So problem 2, problem 3. Now that's great and all that, but if we run the code, it's not going to do anything. Why is that?
You didn't call me.
Yeah, we've defined everything, but we don't have, it's like printing out 3 maps, but you never actually hand the map to somebody and tell them to follow them. So we could just stick that at the bottom, but I've told you all the problem with doing that is that if we ever then imported this code into another module, it would execute them all immediately, which is usually not what you want. So I'm going to do this. Remember that these are double underscores. Save me the time while walking around doing walkabout. If underscore name underscore underscore. See, I only said single, but it has to be double.
I think it has to be all caps.
Equals, should it?
Is it? I don't know.
No. Alrighty.
So I typed it out and I have the PyCharm gave me a red line under main, so I was just
You using PyCharm? Is that why it did it in red?
yeah,
Okay.
just a red underscore. Oh, I didn't put it in quotes. That's what it was.
Okay. Yeah. Honestly, I'm surprised it did that though. Why didn't it just think that main was another variable? Don't know.
Well, it did think it was a variable and that it wasn't defined, so it
Okay.
didn't like.
Makes sense. Alrighty. So now the program should work exactly as it did before. So scrolling from the top down to the bottom. There we go. When we turn these into modules, we need that def statement there, and everything underneath it needs to be indented. If you have a return statement that's not indented, then it's a syntax error in this language. By the way, if I keep slipping up and calling it a module rather than a function, I apologize because a module in Python is something slightly different.
And I'm making corrections every time you do it. That's
Good.
So that helped a little.
Okay, cool. Right.
Sticker.
So what do we want it to do now? What I want it to do now is say, press A for this, B for this, or Z to exit, that kind of thing. So I need a loop. There's always 10 ways to write a loop. Where am I going to put it? I think I'll put it in main. We could put the menu, though, in its own method, but that's almost useless for at this point. So let's print out our choices. Well, we need to define our loop variable first, because you can't loop on a loop variable unless you have your variable defined first. Okay, so it doesn't matter what the choice is to begin with, as long as it's not the one that would cause it to exit. So then while choice is not equal to, let's just make it Q for quit. Everything under a while loop has to be indented. But you know what? I'm just going to comment those guys out for now. I know I'm going to need them later. Now we need to ask them what they want to do. Choice is equal to input problem 1, 2, or 3. Not that we've done problem 2 and 3, but you know, you get the idea. Now in this case, since we're not actually doing math on it, well, since I have Q here, I should tell them that that's one of the options, or Q to quit. I'm not going to convert it to an int. For one thing, if they type in Q, you know, that would blow up. I could have made them letters, or I could have made it 0 to quit, whatever. Now, if you've taken a programming course where they taught you switch case statements, it's a pity that Python doesn't have them. So if choice is equal to 1, I'm having to put quotes around it because remember that input returns strings and we didn't convert it to a number. So if choice is equal to 1, call problem 1. Now problem 1 is not even defined yet, so I'm expecting that to perhaps be a compilation error and certainly a runtime error if it's not a compilation error. The difference between a compilation error and a run, you know that.
Problem 2, you haven't written anything.
Exactly. I haven't written problem 1. I'm curious whether that's just going to flat out not let it run or if it would only fail if I chose that. Else, if choice is equal to 2, colon, problem 2. Else if choice is equal to 3, colon, problem 3. Now I don't need to do else if choice equals Q. I could, I would just make it say okay, goodbye, something like that. But I don't need to because we're at the end of our while loop now, so it's just not going to do anything. It's not going to do any of those choices. But it would be nice to be able to print bad input. And in order for me to be able to print, invalid input, I would need to do that Q choice. Now there are other ways of narrowing down whether we have good input or not. Validating it even before we go into the if-else-if, cascade. But else if choice is equal to Q. Print. Okay, done. And then one final else, which says print invalid choice. Right, because we didn't execute anything. And we're going to blame it on them. Like they typed in a lowercase q. Shame on them. Me personally, I like putting little comments at the end of a while so that I get my indentation levels right. And although I didn't do it up above, I like putting return statements at the end of all my functions. But since I didn't do it up above, I guess I won't do it this time. If I did this correctly, what I'm curious about is whether it's going to crash because we don't have, well, I know it would crash if we actually executed it, but whether it'll even run with that function not defined. Nope. For one thing, there's no such thing as else ifs. What is the correct?
Elif.
Yep, elif. So everywhere I had else if.
Oh, I just did that without thinking about it, actually.
Yep. That was the professor having a brain fart. So there we go.
When you teach multiple coding languages.
Yep. And I didn't make my input look very good. Okay. So it did run, but when it tried to execute problem 1, it couldn't because we didn't define that function. That's fair. If I wanted to actually send this to the customer, I would instead replace that with a print message, saying, 1 not implemented yet. Call your programmer and fire them, whatever, rather than just have it crash. This language is not it's not strictly typed, meaning you don't have to define your variables before you assign a value to them. So in this language, that's not a syntax error. The program wouldn't run, but it's not a syntax error. Excuse me, the program would run just fine. Well, let's run it. But it's not going to give us the output that we want. No matter what I type, it's going to say invalid choice. But it didn't crash. The reason why is because in some languages, in many languages, you'd have to define this variable first, and then this one would give us a compilation error because it had never been defined. But in this language, the act of assigning a value is defining it. So that just creates a second variable, and the first one never gets changed. So that's why it's always printing invalid choice. So typos can be subtle in this language because it doesn't hunt them down for you with the same rigor that a strictly typed language is. And a strictly typed language or a strongly typed language is one where you define each variable and you give it a type, and then if you tried to store something of another type in it, it would give you an error. So for example, don't type this, but if I typed in somewhere up here, int x is equal to 0, that means that x is an integer. This is not Python. I will reiterate that. And then if I tried to do something else like that, it would give me an error. That's more C style or Java style. These scripting languages like JavaScript or Python are real loosey-goosey, and they let you reuse variable names for whatever you want. It's not strictly typed at all. So correct me if I'm wrong, but we've hit the idea of functions pretty hard, have we not? DEF function name, and inside the parentheses we have values. Have we done that enough? I'm seeing some people nod yes. Hope so. Okay. So we're going to go to 5, iterating. This is in the online text. They kind of sync up by chapters, but not precisely, even though the things have the same name. Okay, so the while statement. The idea behind the while statement is that this is an expression that has to return true or false. That's a Boolean expression. It could just be the word true. While true sets up an infinite loop, or at least it would be an infinite loop if there is no break or return out of it. And when I'm typing code in up here, my urge is to use a loop of this form. I'll show you what I do, and it's not considered strictly correct by the books that you read. But if you do this, while true, and you don't have to type this in, you know, input A, that's not the right syntax, right? If, or X, if X is equal to Q, then break, like that. That is a totally valid loop, but it's not the kind of loop that the books show you. So if I say use a while true loop, or if I demonstrate one, that's fine. That's just saving me from doing it the way that I did it in the assignment, where I first had to define, you know, X, and then I did while, you know, X is not equal to our sentinel value, you know, that. For some reason, I like doing it that way better. It's not the book way, though. I only say that because, probably, pretty quickly, I will wind up doing that. So if we analyze what's going on here.
And true would be capitalized.
Yep, in this language, you capitalize your trues and your falses. Thank you, Mr. Python, for inventing it that way, just to make my brain hurt. Okay, so what's going on here? That's a Boolean expression as well, but it always evaluates the true, right? An expression could even just be a single variable or a constant, in which case that's, you know, a constant. And so it's going to repeat infinitely until somebody types Q. What does a break statement do? It exits the loop that it's in, regardless of the loop type. Could be a for loop, could be a while loop. I think those are the only kind of loops we have available to us. But anyways, bails out of that loop. So it would then execute this stuff, or whatever was after that. If I'm remembering correctly, there's a variation of break called continue. What continue does is instead of breaking the loop, it comes back up and immediately starts to reiterate it. Runs back up and let's play with that. So,
I know pass will just skip like the if statement and go on.
Yeah.
In this case, pass would be the same thing as that.
Let's see. I'm going to start a new file, gang. So I'm just going to test that out. While true, X is equal to input, don't type a Q. If X is equal to Q, break. But let's also try a continue. If X is equal to C, continue.
It seems to be
And then print Q, or whatever. Okay. So we look at what this is going to do. Once we get the input, if they type in a Q, it's going to break and run down to the done statement. If they type in a C, continue tells it to stop the loop, but instead of exiting it, come back up to the top, check the condition again. So if they type in C, it's going to come back up here and immediately say, don't type a Q, and whatever they typed in, you know, it's going to continue. If they typed in neither a Q or a C, it will print Q, and then it'll loop. So that's what continue is, as opposed to break. Break bails out of the loop. Continue forces an immediate reiteration of the loop. That's while loops are not the only kinds of loop you have. You have ranged loops. A ranged loop looks like this. For X in range 1 to 11, colon, print X. And don't save that in your root Python directory. Feb27b. Don't type a Q. Okay. Now you see, since I did not type either a Q or a C, it behaved as you would expect a loop to do. It repeated all of the code in the loop, and then it jumped back up here, reevaluated it, and since the condition was still true, we're back to that line. Now I'm going to type in a C, and it forces a continue. So it ran the continue, meaning that it immediately jumped back up to the top, and it did not do the whew statement. Now, if for some reason our condition is changed, if this is no longer true, if it was like while x is not equal to 0 and something has set x equal to 0, then when it reforces the iteration, it does do the check first. And then if that condition was not true, it would bail out of it, just like it was a break statement. So that's what continue really does, is it's just like a go-to while loop header.
Restart.
Yeah, it's a restart. I wish it was a restart. Yeah, whatever, but it's continue. This one down here, what this does is it would print, or loop, from, I need to put this as a comment, from 1 to 10. Annoyance factor. Notice that this is the starting point and it is inclusive, but this is the ending point and it is exclusive. So it really is going to count from 1 to 10. So if in a quiz I tell you write code that prints 1 to 5, and you do a range of 1 to 5, that's not correct because that would just go up to 4. The way you really read this is start at 1 and then stop when the number hits that. There are more than one format, 3 versions of the range statement. If you only do one number, it assumes it's going to start as 0. If you give a starting point and an end point, you can also specify
Count by 2s?
Exactly. So this is going to count from 2. I wish it'd count to 20. I've already kind of broken what I wanted. So this is going to count from 2 to 18 by 2s, right?
2 to 22.
Yeah. If I wanted it to actually go up to 22, I'd change that to 21 or 22. Suppose I should run it, make sure it actually works. All right, no syntax errors, I'm happy enough.
Don't type a Q. I'll do what I want.
Yeah, I'll do what I want. Okay, so we've seen 2 kinds of loops here. The third kind is when you're iterating through a list. We could demonstrate that in more than one way. For x in, and the way you define a list is with square braces. Or heck, red, blue, green. That will print 1 per line, red, blue, and green. There are other ways to write that. Once we learn more about lists, I'm assuming that y'all have already had some exposure to lists. There are other ways to write that, but that's the most succinct way of doing it. The other way we would be able to do that would be to use an index into that list. But to do that, we should store the list as its own variable before we go into it, which we could do. We could do L is equal to, and then make it a list. 8675, like that. I'm getting really tired of copying and typing that print x, so I'm just going to paste it. There we go. I forgot to put the for loop in it first, so for x in L. There we go. Should you be using single letter variable names like I do? Not really. But for counters and iterators, I don't mind using single variable letter names. And just for demonstration purposes, I don't mind doing it. Okay. So we've seen while, and we've seen broadly 2 different versions of the for loop. We've seen the ranged for loop and the list-based for loop. I've never settled upon a perfect name for these two. Range is pretty easy. You will see this syntax in other languages, except they call it for each. Like in C++, don't type this. In C#, you'll see for each X in L, like that.
Oh, yeah, I remember doing that in Java.
And in Java, it would be for
Yeah.
int X, or string X, whatever, int X in the list, like that. So you've seen these before if you've taken another language.
For each is also a different, that's, in Java it would be for each with that syntax.
Java doesn't have the for each word, so you have to do it like this.
I don't know, I used for each in Java.
Has to have been added.
It wasn't for arrays. Maybe it was two separate words.
Not going to argue right now.
Yeah.
Prove it to me. Take a picture of it. Send it to me.
I don't know.
I'll give you a
4
bonus
years ago,
point.
so.
Okay. Anyways, I did not think that it worked. I know that the syntax I demonstrated does work, but they're always evolving the language. C# updates itself to copy stuff in Java, and then Java updates itself to copy stuff from C#. So they're always neck and neck.
The regular for loops in Java don't use the colon.
Exactly. So here's their example. N is equal to 5. While n is greater than 0, print n. What is it going to print? What is the output going to be? Obviously, it's going to print 5. But it's going to print 5, 4, 3, 2. Is it going to print 1? Yes, it will, because it keeps going as long as n is greater than 0. But is it going to print 0? No. It stops at that point because the condition is no longer true when n is no longer. That evaluates and that's false. What if you actually wanted it to get down to 0? How would you change this?
Put the n equals n minus 1 before the print statement.
Well, then it would print from 4 to 0.
And change it to 6.
Yeah, okay. So what I would do, if I wanted to stop this to count down to 0, you could do n greater than equal to 0. That way 0 would still be a valid state. Or you could do while n is greater than -1.
Yeah.
Or while n is, something like that.
Not less than 0.
Right. So an infinite loop is one that repeats forever, meaning that the condition is never false. So if we did not subtract anything from n, then that condition would never be false and it would repeat infinitely. But of course, if you add a break statement to it, as I mentioned, it is no longer really an infinite loop, although the possibility. So infinite loops and break. Here we go. While true, I'm proud of this textbook for actually mentioning it.
That's an infinite.
That is an infinite loop. But, well, why didn't they demonstrate it there? Okay, anyways. If you put some kind of if statement with a break, then it would break out of it, even though it's a while true loop. Finishing your iterations with continue, I demonstrated that. Definite loops, using for. That's what they're calling it. Here they have defined a list called friends, and then for every friend in friends. Now, I think this is a perfect syntax. Make your list plural, and then make your iterator variable singular. And I've learned through bitter experience that anytime I do that up here, people start putting S on that one, or, they mix up the single and the plural, so I don't make my variables that similar.
It's really hard to troubleshoot because they look really similar.
They look too similar, so I don't do that. But you can. It's a nice way of doing it. Conceptually, it's nice. So this would print Happy New Year, followed by whatever friend we are on. So the first time, friend is going to equal Joseph. The second time, friend is going to equal Glenn. And the third time, Glenn is going to equal Sally. So loops in general, if it's not a while true loop, follow the syntax, or the conceptual scheme. You initialize your loop variable if you're going to iterate through a list, you'll probably initialize your list. You won't just do a constant like I did in that red, green, RGB list. And then you perform some computation on the values of the loop inside your loop. Whether you're printing them out, you're creating a sum or something like that. Let's do a loop that will count all the, calculate the factorial of all the numbers, of a list of numbers. Well, let's come up with our list. Well, hey, we already have a list of numbers, eh? So, for x and L, unfortunately, we need, no, not unfortunately, but we have to define our accumulator variable before we enter the loop. Or else, because if I did this, fact is equal to fact times x, that's a syntax error because we have never declared fact. So, if I was going to do a summation, I would set fact off as 0, but I can't do that because 0 times anything is 0. So instead I have to start fact off as 1 to calculate a factorial. Sorry, I threw in a math term. Factorial is 1 times 2 times 3 times 4, whatever, whereas summation is 1 plus 2 plus 3 plus 4, that kind of thing. And then let's print it out. Fact of, comma, or quote, comma, the list, comma, quote, is, end quote, comma, fact. I should just say the product. I don't think it's a correct factorial if it's not a sequence, 2, 3, 4, 5, 6, 1 through whatever. Alrighty. So that seemed to work. So you set some stuff up before the loop, typically. In the body of your loop, you act upon that data, and then once the loop is done, you process your result. By process, you print it out, you write it to a disk, something.
What was the outcome again?
Oh. Yeah, thanks. I think I hit Q.
Well, it'll be 8 times 6 times 7 times 5.
Yeah.
If you have the same ones. Yeah, I don't think it's factorial unless it goes
Unless it's a
sequentially
sequence. Yeah.
Or it's 1.
1680. If we filled in different numbers here, like 1 times 2 times 3 times 4, it'd be 16, I think.
It gave me more than I asked
No.
for.
Pardon me?
It gave me like a...
Did you put the print in the loop?
Let me come look.
Oh yeah, I did.
Yeah, if you put the print statement here, then it'll
It
display several lines of output. 1 per element of the list. Which is cool to see.
It's 8, and then 8 times 6 is 48, and then 48 times 7
Yeah.
is 336.
But it's not strictly, that's not strictly true. These are all intermediate
I
steps.
mean-
We'd have to reword it to make
Yeah.
it sound look good.
No.
Anybody getting syntax errors or need type time? Let me come look. Campus ought to use all their computers for like BitMine, Bitcoin mining while students aren't using it.
None of them are going to be even moderately good at it.
Right,
Like, there
these are all way too slow. By the time they calculated a Bitcoin value, it had already been snatched by somebody else because
Yeah,
they're
but
slow.
there are a lot of them.
Yeah. Okay, so the next section of the text here shows iterating through a loop in order to find the maximum and the minimum. Now, honestly, you can calculate the maximum and the minimum by using the built-in functions. So remember, we have this list already defined. So I could just do this. Now, I hate that I can't just say max is equal to max. You know, that variable name is reserved because it's a function. So I'm going to call it max v for max value is equal to the maximum of our list. That's a built-in function. Min v is equal to the minimum value of that list. But we are way cool people who want to write our own max and min functions. So what do you got to do? You got to set your max value equal to the first one of the list, and then you iterate through it, and then whenever you find one that's larger than the first value or that your current value, you make that one the new max. Does that make sense? Like if I'm trying to find the oldest person here, I get Denise's age, she's 7. Okay, then I go and I ask you how old you are. If you're 3, nope. So the maximum age is still 7. I go to you, you tell me that your age is 12. Okay, we have a new maximum, 12. And I ask you, your age is also 7. That's a lot larger than 12. So after we've gone through it, then our max value would in fact be 12. So again, we're going to do that pattern of we're going to set up some kind of data. We're going to iterate through the data with a loop. Inside the loop, we're going to, perform some calculations, in this case comparing values. And then after it, we're going to display some results. So for x and l, nope, I've already forgotten that I need to start off. I'm going to call this one C max for current max. And it needs to be equal to the first value in the list, or it needs to be equal to the smallest value that the language can hold. And I've forgotten how to access that, so I'm just going to set it equal to the first value in the list. And I'm sorry that we're hitting lists so much in this chapter. What this means is the first value of the list. Some languages call this an array. This language is calling it a list because the difference between an array and a list is that an array is not resizable while a list is. So this language does not support lists arrays per se, but the syntax for accessing them is the same.
There's not really a reason to use arrays if this is
Not if you have nice lists like this. That's correct.
Especially if they're this easy.
So for value in the list, I'm trying to calculate the max. So if that value is greater than our current max, that becomes our new max. C max is equal to val. And by the way, guys, if you just picked up from here because you were still working on the other code, for this code here to work, we would have to have our list definition above it. So if you miss the other part, at least have that. Okay, and then we could print out C max at that point. Print the max of, end quote, comma, the list, comma, is, comma, val. Nope, not val, C max. Like that. You could calculate the minimum the same way, except you would make one change, besides changing the name of your variable, because you wouldn't want to call a minimum a max. What line of code would I want to change if I was going to make this looking for the minimum?
The if statement, the if one. And you would switch on the
Everybody agree with that? Too bad, because I wanted somebody to get it wrong. No, I'm kidding. That's right, that's right. Okay. So, that's how you calculate the max with a loop. Perfectly valid way to do it. They give you a function, a built-in function to do it, so you don't have to do it that way. But I would kind of like y'all to memorize that. That's more like a fundamentals of programming thing. But anyways, do memorize this. Or determine the max of a list with a loop. Alrighty, if I can remember from now on, I'm going to use this textbook's definition, or term, loop. They called it a definite loop. So, what is a definite loop? It's the one that says for value in list or for value in structure. Anything except for a range. It may even call it for a range, but for that I would continue to call it a range-based loop.
I would call it a list loop.
List loop, I like that, a list for. I'm not going to even write the minimum. You can figure that out based on what we have there. Alrighty, so glossary. What is the counter? It's the value that equals 1, 2, 3, 4, 5, 6, like in a for loop. A range-based for loop. What is the accumulator? Holds the result. We've used a couple of accumulators here. We used one. What was the first one we used? Besides Cmax, which is not really an accumulator, but it sort of fits the definition, we had another accumulator. It wasn't the result of addition, though.
Yeah, when you.
It was that one. Right. Incrementing is when you up the value. Decrementing is when you lower the value. Initialize is the first time you assign a value, one that will continue to be updated. An infinite loop, we know what that is, and an iteration is one pass through the loop. So, write a program which repeatedly reads numbers until the user enters done. Once done is entered, print out the total, count, and average of the numbers. That's not a bad thing to do. It'd also be a good homework assignment, but let's go ahead and do that. So, ask the user for numbers. When done, print the count, total, and average. What is the count? You know, it's just they enter 10 numbers. Then count is equal to 10. I'm feeling like defining all three of my variables here before we go into it, although I don't think we would technically have to define the average before the top. So right now, when we start, we don't have any data, so the count is equal to 0. Our total is equal to 0. Our average, we can't even calculate because the average is equal to the total divided by count, but I feel like defining it up at the top. Not necessary. Now this, to me, seems like a good case of using a while true loop. So I'm going to do it that way. While true, let's get the value. N is equal to input. Give me a number, or Q, to stop. I can't convert it to a number yet because it's possible that they typed in non-numeric input like that Q. So we better check that first. We're gonna, if you use this syntax of using a break, a while true and a break, I always recommend making the check for the break the first condition. And really, if you have more than one break statement in your loop, then you're constructing it pretty oddly, and you ought to, rethink your values in life. So if n is equal to q, it's time to break. At this point, we really hope that they have numeric output, that they're entering a number, but what if they don't? Let's go ahead and handle whether they type in bad data or not. What we're going to do is we're going to set up one of those try except things, And if they give us a bad value, we're going to use continue to avoid adding it to the total. So let's do that. Try this block of code. N is equal to float n. If that works, great. Continue on your merry way. But if it fails, if it generates an exception, then print that's not a number, and then continue, forcing a restart of the loop. Now once we get to this point here, we have a valid number. N should now be a valid number. A couple of weeks ago, we wrote a function to force him to enter good data. Great, if you had that lying around, you could slap that in there instead and you wouldn't have to structure it the way that we did here. Alrighty, so we want to increment our counter. If this is C++, Java, or something like that, we do counter plus plus. In this language, you would do counter plus equals 1. Or counter equals counter plus 1. Don't type in my comment. For some reason, the hard copy textbook completely ignores this syntax, which I think is absurd. I'm going to use it all the time in here. So don't get confused by the fact that the book likes doing it like this. I think the author was slightly brain damaged when... Okay, so anyways, we're going to add 1 to the counter each time. And we're going to add the value of n to the total. So total plus equals n. And by the way, if you take offense at me making a joke like that, I understand. I have brain damage from a stroke, so hey, you know, I should take offense at myself. I'm angry at myself right now. Okay, so there we go. We could calculate the average right now, but there's no need to. I would just wait until the end of the loop. There's one advantage to calculating the average here, though, which is that if you get out of the loop and the total and the count are equal to 0, then it would blow up when you tried to calculate the average. But it bothers me to calculate the average once per iteration because that's a waste of performing cycles. Now, if you're trying to write the fastest possible program, you would not be doing it in Python. But still, I'm going to wait until the end of my loop to calculate the average. How do you calculate the average of something? It's the total divided by the count. Then you'd add 3 print statements, which I'm going to ask you to do while I look up something. We're going to have to stop soon, though. One more thing that I want to show you that I don't even necessarily want you to memorize for now. Just want you to see it. If you wanted to calculate the total in one line of code, besides using the sum function, or if you wanted to print out every value in the list in one line of code, you can use something called list comprehension. And the syntax for that is weird. Print value for value in list. Now, believe it or not, that actually would work. If you wanted to calculate the total the same way, because you feel like writing the most perverse terse code possible. You could do it like that. If you wanted to get the count in this syntax, I'm going to type all three of these things and then I'm going to explain what they're doing. I goofed this last one, I think. I should print them out to make sure. All right, I have a syntax error in my code here. Anybody run into it before I started doing this nonsense down here? You may have typed it incorrectly just knowing what I meant.
I didn't.
But I have the variable named count here, and I called it counter there.
Oh.
So I'm going to change that line there to just say count. So that line needed fixing.
The weird syntax for count that you just did at the end, it just prints out 4 ones.
Okay, so that's
The
a
list.
that's an error. I'll worry about that later. What this does is list comprehension is trying to build a list based on this loop. So it iterates through every value of the list, performing this function, invoking this function on every value in the list.
Yeah, so it prints out each one on a different line.
Exactly. Now this function here could be something that you write as well as, you know, as calling a built-in function.
Okay, that's kind of cool.
So I'm just going to put a comment that this is list comprehension. If it totally clicked this time, great. If it didn't, that's fine. We'll hit it again. Okay. So I need to print out my count and my total and my average at this point. Just the usual stuff. Count equals, comma, count. Print total equals, colon, total. And then print average equals average, like that. And as long as you actually enter some data, it would run well. If you typed in Q immediately without entering any data into the list at all,
Probably did
then it would try to do a divide 0 by 0 and it would blow up, which you could handle with another try except block.
Yeah. Gotcha.
All right, I need to make a Dropbox for this. I think I've gone over our time. All right, there's a Dropbox now, so you can upload your PY script.
Oh yeah, since you already defined average as 0, you don't need the except part. You can put try and then calculate the average, and then otherwise the rest, like printing it out, would work fine.
Right, right. We could put a try there and to capture the error. All right, gang. I'll just take attendance based on y'all uploading. We have a few minutes before I have to scamper off to my C++ class, so if you have questions over homework or need more time to
Actually,
type in
you do
something,
need the except.
But I just want to check.
let me stop the recording.